Hello, today's video is going to be on graphs and function notation within those graphs. Before we get to the actual graph, we're going to look at slope, but we're going to look at it in just a little bit of a different way. So what we want to do is we want to find y if a line is going through the point -2, 1 and 4y and it has a slope. So what normally happens is I give you 2 points and I tell you to find me the slope. Now I'm telling you 2 points, but you have one missing coordinate, and I give you the slope. So what we want to do is we want to find that value of y that's going to give me the slope of 2/3. So start the way you would normally start, y2 minus y1. In this case, y2 is y. So on top we've got y minus 1. On the bottom, we've got 4 minus a -2, which is a +2. And we set that equal to our slope. In this case, we know our slope of 2/3. So everything starts the same way. Now y minus 1, we can't simplify that at all, so y minus 1 stays on top. 4 plus 2 gives us a 6 on the bottom. And we set that equal to our 2/3. Now what we have here is a proportion. So we're going to cross multiply. We've got 3 times the quantity y minus 1 is equal to 6 times 2. So we've got 3y minus 3 is equal to 12. Add the 3 to the other side, so we've got 3y is equal to 15, and y is equal to 5. So what we just found is if I were to take the 2 points, -2, 1, and we found that we have 4 and our y is 5, if I were to find the slope, 5 minus 1, 4 plus 2, because it's 4 minus -2, we would have gotten 4 over 6, which would have reduced down to the 2/3, which was the slope that we were given. So again, all we were doing was trying to find that one missing coordinate that would give us and satisfy that slope of a 2/3. Alright, moving on to our graphs. We have evaluated equations and evaluated numbers for that function. Now we're going to evaluate it, instead of with an equation, we're going to evaluate function notation from a graph. So if you remember, if we had f of -3, -3 is the x value that we were plugging into the equation. So what I want to do is I want to go find when x is -3, so this is when our x value would be -3. We're going to follow that up until it hits the graph, and then we're going to follow that over, and that's going to be roughly about 3.5. So if I were to plug -3 into this imaginary equation of the graph we've got, it would have given me a y value of 3.5. So if I want to find f of -1, again, the -1 is our x value. So we go find where x is -1. We follow that up until it hits our graph. And that's going to be about a y value of 4. Alright, one more like this. Our x value is 4.5, so we go on our graph. Here's 4.5. We follow it until we get to our graph itself, and we follow that over, and that's going to correspond to a y value of about a -1.5. Now there's a little bit of leeway on this. If you would have told me a -1.25, you still would have gotten credit for it. So there's a little bit of leeway. If you would have told me -5, would have been wrong. Alright, now let's take it from a different perspective. We want to find f of x is equal to 2. Now since that's what it's equal to, the 2 is your y value, and you're trying to find out what the x value is. So here's when y is 2, and what we're going to do is we're just going to draw, let's draw a better line. We're going to draw a horizontal line at 2. Now that's not a very good line, so I'm going to redraw that for a second time. It's meant to be right there. Alright, so we have y equals 2. We're going to look at all the different places where that line at y equals 2 hits our graph. So it intersects at 1 place, at 2 places, and at 3 places. that means that I'm going to have 3 different answers here for x. So if I plugged in a -4, I would get a y value of 2. If I were to plug in 0, I would get a y value of 2. If I would plug in 3 for x, I would get a y value of 2. So there's 3 possible answers for x that would give me a y value of 2. Last one, we have f of x is equal to 5. So again, we're trying to find the x value when your y is 5. So we draw a horizontal line when y is 5. I know it's a fabulous line there. So we're just going to show that one intersection point. We follow it down, and that is going to correspond to an x value of a -2. So if you're given the number on the inside, you're given x and you're trying to find y. If you're given the number on the outside, you're given y and you have to find x. Next. What is the domain and range of the function? So we have a graph here. We don't have a relation. The next problem we're going to have a relation. So right now we have a function. What is the domain? The domain is all possible x values. So you always start with the smallest one. Boom, boom, boom. It goes the smallest x value in this graph is a -5. So that's going to be my smallest bound. Graph continues on, and it stops at a +5. So my x values are going to be all numbers between a -5 and a +5. And you're going to have a range, because it can be anything in between a -5 and a +5. It must be written in this way. -5 is less than or equal to x, which is less than or equal to 5. Now, time for our our range. I know that's going to be confusing. So domain, this is a range compound inequality. It's the domain of the function. The range of the function is all possible y values. So we're looking up and down. So first we start, where's the graph the lowest? So the lowest y value. This is our lowest y value, and that lowest y value is a -1.5. Our highest y value, our graph goes all the way up to a +5. So it's less than or equal to y, since it's the range, which is less than or equal to the highest point of 5. So domain is all possible x values, range is all possible y values. This is the left bound, the right bound. This is the bottom bound, that is the top bound. Now within your domain and range, you have a compound inequality that should be written as a compound inequality range. So you've got 2 different kinds of ranges there. And last but not least, finding the domain and range of a relation. So this isn't a graph. We don't have lines connected. We just have scattered points. First thing we're going to do is put the coordinates with those points. So this point right here is 6, -1. This point is 2, 5. And just in case, remember, points are always x, y. So your left shift and then your up, down shift. So here we've got 0, 2, -7, -2, and -7, 7. So our domain of our function is going to be all those x values. So we're going to look at all of the x's. Now our smallest x is a -7. We've got 2 of those. Our next smallest is 0. And then we've got 2. And then we've got 6. So we have 4 different x values. So we have 4 different ones. We're not going to write the -7 twice. That's just being repetitive. Now for our range, we look at the y values. So we've got -2, 7, -1, 2, 5. Again, you want to put them in order from smallest to largest. So our smallest y value is a -2. Then we've got a -1, 2, 5, and 7. So we've got all different y values there. Notice that when we did the domain and range of the function, we had range compound inequalities. That's because our line continued. It was all of the points in between those. Since we don't have a line and we only have points, we only have values at -7, at 0. It's not everything in between there. So this is when you list your individual numbers. Now, is this relation a function? A couple different ways you could do that. You could do a mapping. So we've got -7, 0, 2, 6 as our x's. For our y's, -2, -1, 2, 5, 7. A -7 is going to correspond to, according to our table, a -2 and a +7. 0 corresponds to a +2. 2 corresponds to 5. And 6 corresponds to a -1. Now this would tell me no, because my input of -7 has 2 outputs. And remember, every input can only have one output. Or, which I think is easier, is do the vertical line test. When you do your vertical line test, when I draw that line through a -7, it's going to hit twice. So this is not a function. Or you can remember, if you look at your table, you can have multiple of the same y's, but you can't have multiple of the same x's. So there's 3 different ways you could have checked to see if the relation was a function. I think the easiest one is just to do the vertical line test, which our graph failed. And you are done for today.